Hello, everyone. How's it going? Welcome to day two, day three, near about there, depending on the time zone of GHW. And how's everyone doing? Hopefully, you have been enjoying it so far. And welcome to the last and final, uh, I would say, chapter of our mini SQL database journey. Okay. And for someone who is new today, hi, welcome. Hopefully, you understand what's going on, which you won't technically because we have done a lot. Okay, we have had like 6 hours of sessions on doing things, and if you're joining it just today, it might be a bit difficult, but thankfully, all our sessions are recorded. Okay, so you can always go back on the Major League Hacking YouTube channel and search for build your own mini SQL database videos, and you'll find part one and part two together of like 4 hour session. Part three, where I was kind of like, it was very late for me, and part four, which is this one and the final one. But to give you a quick overview of what we have been doing, we have been learning about SQL, SQLite database, and then we have been converting it to our own implementation in JavaScript. Okay, so that's more or less what we have been trying to do. We are also actually testing out uh, what do you call the real SQL. Yeah. So on SQLBolt, we have been testing out like how does SQL syntax work, and we didn't get much far there. Okay, but if today the time permits, then we'll actually try and complete most of these. Okay, so that you get a better idea of uh, SQL, real SQL syntaxes. Okay, I think this is one of the very good websites for uh, learning SQL. So let's see, depending on the time, probably we'll try and complete most of these. Okay, yeah. So that's a quick overview of what we have been doing, what we have done. And yesterday, when I left you all, we had started implementing locks in our table. Okay, so we'll continue from there. There's a twist today. So, yeah, we'll talk about it. But before all of that, may I kindly request you to please register for the session? Okay. So, the link is in the chat now. Please do register for the session. Helps you, helps me, helps MLH. So, please do. And other than that, let me just set some background music, uh, reduced volume, so that when you okay, perfect. When you come back to this session later on YouTube, you don't have to hear just me. You have some very good, nice background music playing. Okay. So, yeah, let's continue from where we left yesterday. I had not pushed the locks thing yesterday, and well, thankfully, it's good that I hadn't, because I found a bug today, because of which I will need to change the implementation. But if you are interested in getting all the previous code that we have done, it is on my GitHub. The link is in the chat. Okay. So, yeah, please clone, please copy, please download a zip for whatever suits. Please do that so that you have an exact copy of everything minus the locks.js that we had created, which actually doesn't matter. We'll rewrite this whole thing. The structure that I'm planning today, I think the background music is too loud. Okay, much better. So the structure that I have planned today is we'll complete this locks.js. We'll need to create something called as a mutex.js, which we will talk about. Complete locks, complete locks, push it on npm. okay, so that it's out there as a library, that is that I had promised that. Then come back and start doing some enhancements. Okay, specifically one of the things that we are missing is the where clause. Okay, in in our select, which seems to me that I've tried to add, but oh yeah, condition does not work. I had added this, that condition does not work yet. So this is something that we have to fix. Plus I would also like to add some aggregations. Okay, so it, like one or two, again depending on the time that we have. If not, you can keep an eye on the repo. You can, I don't know, watch the repo, I guess, uh, which will, whenever I push the updates, which I will, it takes me sometimes about a week to do that, depending on like how swamped I am with work and stuff. But yeah, I do push updates. My previous sessions are a proof of that. I push updates. So whenever I do that, and we have a more robust library, you can keep a watch on it and get updates. I'll also put it on the GHW announcements whenever I complete everything, or at least, like, just enhance it a bit. Okay, so okay, I think that's a good enough introduction. I've taken 7 minutes of your time, kind of, uh, in talking about it, but let's get to coding. So I hope everyone has the same code base that I have, minus the locks, which is okay because I'm going to delete this and we are going to start fresh. Okay, so create a file called as locks.js inside the lib folder, and at the same time create another file called as mutex.js. Okay, following our tradition, we will have lib/mutex.js. Now what is this mutex.js? Now mutex, the, I would say it's col- colloquial, colloquial, basically a short form, let's say, uh, of two words, or a match of two words, which would be mutual exclusion. Okay, and what it is, that a mutex, you can think of it as a kind of object that allows only one piece of code to access a shared resource, okay, at a time. So yesterday when we went off, we had actually discussed the reason why we would implement locks is that when two operations happen simultaneously, we want to complete one, queue the other, and then once the first one is completed, then the second operation comes forward, and that operation gets completed, and then if you have third operation and so on and so forth, until all the operations are completed. And when one operation is happening, the second has to wait for it to complete. They cannot try and access the database in our case at the same time. There needs to be some, like, you know first come first served basis. So that's what we are doing with locks. So in locks, when we implement this, we would first there would be a task which would be, let's say, inserting into database. So the first insertion is happening, and you have the same, at the same time, a second insertion that's trying to happen. The first insertion would lock the table, update the row, and then release the lock. And then the second insertion would come in and it would then acquire the lock the table, do the update in the, or the insertion in the row, unlock the table, and if there is no other operation after that, then you're done. Okay, and the table is now completely unlocked. The problem that I found with doing it in functions was that for some reason both of them are going into the, what's it called in JavaScript, the, okay, I forgot the term, but basically they are not adhering to that weight. And the only way that I found that it kind of works out properly is by creating a class. Okay, so a JavaScript class, and like doing some functions inside that class. So let's do that. So the mutex is specifically, I'm pulling it out of logs, creating a separate file whose only job is to keep a tally of the queue, lock the table, unlock the table. I also found that in promises, if something is undefined, so if you await undefined, it resolves the promise. Okay. So I think that is also why I move towards and doing it in, what do you call, in classes. Okay. Because for functions, it was acting a bit weird. And I'll have to research a bit more, but for the for this session, I think we can avoid that. So again, following a tradition, module is mutex, and description is implements mutex for managing exclusive access to resources. Okay. Now let's create a class mutex constructor. Okay. So we need to create a constructor. Now this constructor will have two things. This will first have a this dot q, which is an empty array. So this dot q is, this references to the class. Okay, so you can think of it just like we're focusing on the q variable here. So the q is going to be an array which will hold the callbacks, okay, the functions or the callbacks that are waiting to acquire the lock. And if the lock is currently held by another function, like let's say insertion is holding a lock, the second insertion will be queued in this array. Okay. Similarly, we'll also create a locked, which is initially false. So this is to ensure, like this is a variable that keeps track whether a table is currently locked or unlocked. Okay, very simple. So inside the constructor, just two variables to do two things, two different things. Uh, okay, now what next? So now the first method. Okay, so in a class you call it method, outside of it you call it JavaScript functions. Uh, just a naming convention. So the first method that we are going to create is going to be called as lock method. Okay. And what it does is it will return a promise that eventually resolves with a function. Okay. That can be called to unlock the mutex. So what this means is that when we, uh, like whenever we use it, okay, and we will say that, okay, perform this whole operation, like perform uh, 5 different insertions with locks. Okay, so the first insertion happens, and then you will say awaiting the mutex.lock. And once the lock gets completed, you can call an unlock method to release the lock. Okay, so let's write it down. I think that would make much more sense. Once we actually test it, start testing it, I think things would start to make a bit more sense with respect to what I'm talking about. So we'll say new promise, we takes in two things, like there's a promise can either resolve or reject. So for resolving, what we'll say is const try acquire. Okay, so what is this going to do? So try acquire is now going, is a function as we have created, and what it is that it will attempt to acquire the lock. Okay, and since we are inside the lock method, already, we can access the callback. So JavaScript callbacks, like one of the famous interview questions. So yeah, we can, because now the parent can actually access whatever the child returns. In this case, you can think that the parent is lock and the child is try acquire. Whatever this returns can be accessed by lock. And we'll say if not this dot locked, okay, if it is not locked, then we'll first lock it. So we'll do this dot locked equals true. I'm sorry, so sorry about this. And okay, so try acquire, it is first checking if the mutex is locked. Okay, if it is not locked, then lock it. And then for the time being, I'm going to just console log. This is for mutex, and we'll say lock acquired. Okay, and now inside this if condition, we will say, like, you'll have access to this variable resolve. Okay, so I'm going to say resolve, I'm going to call resolve, and this is our way of saying that, like, this variable. So now we'll say that resolve this function, resolve this promise, because I have now acquired the lock. So you can say that, like, you can think that once this lock is acquired, we will say, tell the promise that, you know, we have the lock, and now if someone wants to unlock this, feel free for them to unlock it. Okay, but for that we will actually need to do something like this dot unlock dot bind this. And unlock is something that we still have to create, so don't worry about it. But yep. Okay, so okay, I think this should be fine enough actually. And next is else. Okay, inside the else, so this was when it was not locked, then we locked it, and we said that now that we have acquired the lock, whenever you want to unlock this, you can call this method. Okay, and that is why we are saying resolve the promise, and if someone calls the unlock method, feel free to unlock it. Okay, but inside the else, what if you are already locked? Okay, what if the mutex is already locked? So then at that time we cannot actually acquire the lock immediately. So instead, what we can do is we'll do some console log saying that, oh, lock is busy queuing the request, and then we will try to add the try acquire to this queue, this empty array that we had created. Okay, so the queue will, as now you can understand, it acts as like a waiting line. Okay, and when the lock is released, we will try to run the next function in the queue again, so that the next function can now acquire the lock. So I'm just going to do a console log again saying mutex lock busy request queued q u q u e u e d. Okay, yeah, I think that sounds about right. Perfect. And now we need to call this function, right? So outside of this, we'll just call the try acquire. Perfect. So that is our acquiring the locks complete. Okay, okay, what's next? The unlock method. So let's create the unlock method, And now inside this unlock, so whenever the unlock method is called, at that time it should immediately release the mutex lock, and the next queued operation, whichever is the next operation in this queue, should get processed, right? And the next operation should then try to acquire the lock, and then that will get unlocked and stuff like that. So now inside the unlock method, we will first check if the this dot queue dot length, since it was an array, we can do the length, and we'll say if the length is greater than 0, which means there is something in the queue, there's another function waiting to acquire the lock. In that case, let's say we can just console log for the time being, saying that mutex uh, passing the lock to the next function in the queue. Okay, and now uh, that's what we have console log. But before we pass it, we actually need to release the lock, right? Remember when we did a lock, we said that this dot locked is true. So the currently this whole thing is locked. But before we pass it, we actually need to set this to false. So we'll say this dot locked is equal to false. Okay, now we have actually released the lock, right? So yeah, so this is important because unless you do this, the try acquire will try to check if it is locked. If it is locked, it will keep saying that, oh yeah, it's locked, it's locked, it's locked. That's not what's supposed to happen. Unlock is supposed to free it. Okay, so that is why we are doing this. And now we can simply use the shift, which is that which we can do by doing like in the in an array, you have this shift method, and what it does, it removes the first element from the array and returns it. If the array is empty, undefined is returned and the array is not modified. So we are removing the first element from the queue, or whatever is the current element, and then we can uh, just call it as a function actually. Hmm. Yeah. Okay, so now what we are trying to do is we are trying to call the next queued function, and this will try to acquire the lock again. And because, well, this dot lock is false, so that's why it would try do the try acquire. Okay, because this is what we are checking. Anything else that we need to do inside this? I think this should be fine. Else, okay, else we will say short form console.log, we'll say mutex lock released. So assuming that there are no queued attempts ever, not ever, if there are no further things in the queue, that means that no one is actually waiting for the lock. Okay, and when someone is not waiting for the lock, we can simply just say that, okay, all the locks have been released, and for anyone who's next can like do something else. So we need to basically do this dot locked is false. Okay, we are setting this to false. I think this should be good enough, and we can just do a export default mutex. uh Reading this, okay, I think this should work out fine, I feel. uh Okay, now we need to use this inside the logs. So let's call our, like, create a new file. Okay, let's start by creating a new file. I think, yeah, this is a good description. Like, we are doing a table level locking, and we are going to use mutex. So now we are going to call import mutex from /mutex.js, and kind of can do what we did yesterday, which was create a new map. Okay, so const table locks is new map. This is what is going to keep a track of all the mutex instances. Okay, and let's create our first one, which is lock table. Okay, so what it does, it acquires a lock for a table, and it would take a parameter which is string, and that would be the table name, which table to lock. Okay, and what it will return is a promise. Promise with a function, that a promise that resolves to an unlock function. Okay, and now let's do a export async function, and we'll call it lock table, of course. That takes in the table name. Yep, it works. And now we can check if not table locks, the map that we have created has the key. Okay, which key? The table name key. So if this is not in the map, it's not in the map there, in that case we'll just call it table locks dot set. For this particular key, the value is going to be a new mutex. Okay, initializing our class. Okay, and we can do log info, I think should be good. So log info, and inside this we can this is coming from a logger that we had created. Okay, for someone who's joining today, we had created our own logger implementation of a logger, so that we can log stuff to the console and make it like pretty and colorful and stuff like that. Okay, so log info, yeah. What we are trying to do is we'll just say that this is from the lock, and we'll say mutex created for table, double inverted, and dollar table name. Okay, and now that the mutex has created, we can just say const mutex, a variable right here, table locks dot get the data of table name and not table locks. Yeah, okay, and we can create a const unlock equals await mutex dot lock. No suggestions. Wonder if I should use TypeScript for this. And we can again do a log info saying that lock actually acquired lock acquired lock acquired for this particular table, and we can return the unlock. Okay, so what we are saying is that whenever you use this particular function on a particular table, so let's say you use it on users table, so first it will check if the users table is already locked. Okay, for the first time it is obviously unlocked. Okay, when you're running it for the first time it's unlocked. So that is why what you would do is uh, you will kind of take it, pass it, uh, you'll just kind of check. Yeah, you'll check if it is in, if it is locked. If it is not unlocked, wait, what am I saying? Okay, let's think about it. So we'll create a separate function which we'll call it as perform with lock, which we had actually created yesterday as well. What it would do is it would, like, we will inside the perform with lock, we'll add a few things like insert into queries. Like, that is one of the examples that I keep going back. We will say that insert into the users table that we have created, and we'll write, let's say, two or three insert into table. So for the first time when it runs, and we'll wrap our insert into query with a perform with lock. So perform with lock is a parent, insert into is going to be a child, and when we run that, perform with lock will first check if the users table is locked, or is in the part of this map. It is not going to be in the map, of course. So it will try to add the table, and it will initialize a new mutex. The mutex has two things. It has the locked variable, okay, and it also has a queue. So it will add it to the queue. Once it is added to the queue, the operation will perform, and the second insertion at the same time, okay, has now come in. It will try to check that, okay, there's a second insertion that's trying to happen on the same table. In that case, it will check if there is a map with the same table name. Yes, users table is already locked. In that case, we'll send it to the mutex and say that add this to the queue. Okay, add it to the queue of the users queue that you already have created. It will add it to the queue. Then the third insertion will come in, and it will check, uh, where are you trying to insert, in which table. Oh, you are trying to insert in the users table. I'm already tracking it. So let me send you to the mutex, where it will add the third insertion to the queue. Now the unlock is basically waiting for the mutex dot lock. uh, if that has happened, in that case, pass it to the unlock variable, and we'll say that, oh, this table is locked and there's this unlock whenever you want to unlock. Okay, you can call this unlock later. So now we'll call it actually in the perform with lock function that we create. So we can say this actually executes a callback function with a table lock, and a param string. It will take in the table name, of course. Okay, the name of the table to lock, and it would take in actually another parameter which will actually be a function, and we'll call it callback, because that's the easiest name and easiest way to understand. So this is the operation to execute when the table is locked. Okay, this is important. So when the table is locked, what do you want to do? So export async function perform with lock takes in two things, table name and callback. And now we can say const unlock is actually equal to await the lock table that we have created. Okay, so await the lock table, and it needs the table name. So let's pass it that table name. Perfect. So okay, let's add some more things and then we'll try and understand. So try, catch, and finally. Okay. Yesterday I only went for try and finally. I think that was also one of the problems in my code, that when I did the try and finally, somehow I messed was missing up undefined and stuff. I had to kind of go back and rewrite the whole code, and it would still not work. So then I had to Google search about how do you actually do this. I found Java implementation, which I kind of converted to JavaScript, bare minimum JavaScript. So there are a few things that are still like, a bit hazy about it. Anyways, going back, so log info, and what was log info doing? Param message and the args. Yeah, okay, perfect. So in this case, we'll say performing operation on this particular table. Okay, and now we are going to await for the callback. Okay, so await callback, yeah, it does not mean waiting for the callback. It is more like execute whatever is the next function. In our example of insertion into the table, we are waiting for the insertion to finish. For catch error, we can do a log error, right? And inside this, we can just say log error during operation on table name, and whatever is the error, let's print that out. And we can kind of stop this here by saying throw error. Okay, if this is a new syntax for you, then throw is basically like calling a function. Okay, no, calling or executing or printing out a variable, a function, a method, or something. So yesterday we were doing this throw new error, where we were initializing this error uh, class and passing it some data to actually print out. Right now we are saying that this error that this catch already has in the syntax, just kind of throw that out and print that out. And finally, once everything is done, we will call the unlock. Okay, where is this unlock? This one. Okay, it's coming from the lock table, because lock table will eventually like get unlocked, like return a unlock. So yeah, just doing that. And we can just do a log info again and just say, okay, inside the backticks we can go for lock released for table name. Okay, I think this should be fine enough. I think this should work out. Let's test it by going into our test db, and I'm going to go all the way to the bottom, hit a few enters, and let's start with this. So we'll create a async function. Okay, the name would be test blocks underscore v1. It does not take any params, so I can remove that. Now what we'll do, we have so much to do actually. So first let's do a try and also do a catch error. Okay, so inside the try, Let's create an array of insert queries. The first insert query, uh, we can copy over what we had before without the semicolon, of course. It needs a comma. So insert into users, ID, name, age, student, and values. And let's say this is 107. I'm bad with names. Okay, Eve and 23, and is a student true. And we can copy paste this again, and this time it would be 108. Josh 29 is a student false. Okay, so these are our insert queries. Now let's create a function to perform the insertion with a lock. Okay, so we can say const perform insert. It takes in the query and the task name, and this actually calls the perform with lock, okay, which takes in the table name. In our case, we know that the table name is users, so I'm going to pass that. And then I'm going to say, like, the second part is the callback. So I'm going to say that is going to be a asynchronous operation, and we can just do a log info, and we can just print out something. Or we can actually use the logger so that it's like, magenta color. So logger, and this would be test magenta console.info, and it starts, it basically should say inside the backticks, we can say that the task name, okay, which comes from here, task name, started. I think, okay, this should be good. So task name has started. Then we'll call the insert into. This is a function that we had created in, I'm not sure which first session or second session. And since we are looping over, okay, we are going to loop over it. So this query, so one query at a time is what we are going to call. So I'm doing the actual insert right here. And then we will say await. So let's add some processing delay to this, okay? Let's assume that inserting into this row takes around 5 seconds. Example. So await new promise and set timeout. Resolved and 5,000. Okay, so this is 5,000 is 5 seconds. So let's say inserting the first thing, like this insert into query takes 5 seconds. That's what we are trying to simulate here. And then also the second one will take 5 seconds, of course, right? And now we can do this logger again. Copy, paste this here. Completed. Okay, so that should be good. I'm still thinking. Okay, let's create another one. Okay, I'm still thinking. Will this work out? Const promises is going to be an array, and we are going to perform one insert at a time. So I'm going to call the perform insert. and then I'll call the insert queries, that is the array that we had created, insert queries of 0, and we will give it a name. Okay, perform insert takes in the query and the task name. So this is the query. So the first query is what we are giving, and the task name we can call it like task 1. Okay, example. Similarly, we can do it again. So I'm going to copy paste this thing, and now we are going to pass it the first thing, and we'll call it task 2. Yeah, perfect. I think this should be good. Now what we want to, so what we are doing here is we are trying to initiate both of the insert operations at the same time. Okay, because this should not take too much time to actually go into insert, but we'll wait for uh, but when it goes inside, it will actually try and wait for, it should, and that's how we'll know our locks work. Even though both of them try to get inserted at the same time, it should wait in the queue for the 5 seconds. Once the first operation goes in, the next operation should wait in queue for 5 seconds, and then the second operation should work. And now we'll wait for both of them to actually complete. So promise dot all settled, which is I think a new syntax that came in recently. I mean, when I say recently, let's say it's 1 or 2 year back. And I think we can just do a this logger that we had created, s this, and locks test passed. Else we can just do simply log the error. uh, this would be console dot error, locks test failed, comma, error. Okay, this looks good. Don't need the log info right here. And test logs v1. Okay, let's call this. Okay, fingers crossed. Hopefully this works out well. And we will know that when I actually run this. So I'm going to actually put it on the right hand side so that we have the whole length available. Also going to make it a bit small. And now let's do a node and run our file. It starts mutex created for table users. Okay, mutex lock acquired, lock busy, request queued, lock acquired for table users, performing operation on table users, task 1 started, row inserted, task 1 completed, lock released, lock released. What happened to task 2? Let's see what happened to our task 2, and at the same time let me see if the data was actually inserted. So okay, only 107 was inserted, 108 was not inserted. So what did I miss? So mutex actually waits for something, which is nice. Let me rerun it. So task 1 task 1 completes. It takes 5 seconds. That is good. Release the lock. That is good. But then it does not start the second task because the queue is erroring somehow. Let me go through the code again. So we're creating a class constructor. This is fine. For the lock method that we create, we return a new promise with resolve, and inside that we do a const try acquire. If not this locked, then we return it as true. Then just doing some console log saying lock acquired, and then resolve it this dot unlock dot bind it this. We're saying that unlock function is now bound to the current instance, right? So else we will see, this is what I missed, right? So else, while we actually did a console log, we did not push the try acquire. The second item never got the chance to actually do or acquire the lock. So yeah, I just did a console log and I forgot to actually acquire the lock. Nice. So smart of me. Uh, okay, let's run this again. Okay. Mutex lock acquired, lock busy, request queued, which is nice. Lock acquired for table users, performing operation on table users, task one completed successfully, and passing the lock to the next function in the queue. Lock acquired, lock released for table users, lock acquired for table users. Nice, perfect, done. Okay. Whew, this was such a pain. So let's go over it. Let's go over the output properly. Okay. So what do we have here? We started with, first, a mutex is created for the table users, because on the users table is actually what we are going to perform our operations. Okay, so that's the first thing. Then from the mutex perspective, now it came inside the mutex and it said lock acquired, and when the second operation came in instantaneously, okay, the second operation comes in instantaneously. And actually what I could do is, we can change all these console logs to log info or log debug, okay, just so that it's a separate color. Yep. Okay, perfect. Much more timing and much more precision right here. So lock mutex created for table users. So now we know that we are trying to perform the insertion operation on table users. We are creating a mutex, uh, which was, where was it? It's in the lock, and it's this one. Yeah. So initially there was nothing in the map, so it's first trying to actually create the mutex, which is nice, which is what it is supposed to do. And wait, clear this, sorry, should not move this much. Okay, so lock mutex created, then we are saying that mutex lock acquired, then the lock busy. So why is this happening? Because we have two insertions trying to happen at instantaneously, like at the same time. As you can see that the timing is actually exactly the same. And now it says, it goes in and it says that, okay, lock acquired for the table users, performing operation on table users, and task one started. This is from the first insertion. Row inserted in table users. Now task one has completed. Now we are coming back to the mutex and we are saying that passing the lock to the next function, because there is something in the queue, right? So again, the second insertion actually takes the lock. Then okay, for some reason it's releasing the lock and acquiring it again, which should be fine actually, because it's happening instantaneously. I would have assumed, I'll have to debug this, that oh yeah, the table should release the lock. The first one should release the lock for the second one to actually acquire the lock again. So that is why the table is unlocked and then simultaneously locked. Then the second operation happens. Row gets inserted into the table users, task 2 is completed, lock is released from the mutex side. Okay, mutex is saying there's no other operation in the queue. I'm releasing the lock. The lock, the locks.js, inside that there is this unlock. Okay, finally, that finally thing, that is what's being called here, and it's saying that okay, we are releasing the locks for the whole of the table users as well, and that's how we end up with lock passing. And now if I go over to my users data JSON, it should have two things, right? 107, 108, two insertions happening one after the other. And that actually concludes our locks as well. So I think this was a hell of a journey. I'm going to move this to bottom again, and let me push this whole code so that you have it. The white is too bright for me. What did we do? We added locks.js and mutex.js. Perfect. So now the latest code should be available to all of you. Yep, I think this should be good. And what are we going to do next? Now that it is all pushed, and as I had promised, let's push it on npm to create a library of this. Okay, so that next time you want to use it, you can actually use it. And when I say use it, what I mean is uh, you can download this library, and whatever we did inside the test file, okay, that exact things you can do in a new node.js project. So like, let's say you create a new node.js project and you want to uh, create a database, a temporary local database. You can use this library and then do some SQL-like syntaxes to create a database, insert into the create a table, not a database, create a table, insert into the table, uh, perform some queries like the select operations, create index for faster searching. So if you are actually reading like, so have you heard of the 1BRC channel challenge? Can actually share it on the screen. So this 1 billion row challenge. Okay, and the challenge is, can you calculate the min, max, and average of 1 billion temperature measurements? Okay, so using, like, some people have done it. Initially, the challenge was to do it in Java. Okay, in Java, if you can read 1 billion rows and perform the operation like of like calculating the min, the max, and the average of temperatures, uh, like as quickly as possible, and the leaderboard is apparently like 6 seconds is the shortest time it takes to read 1 billion rows, and it's very difficult to comprehend 1 billion rows. So now in this case, supposing it wasn't 1 billion, but let's say if it was 100 million, then you could actually add that data in the database that we have created, create index on that database so that it's very quick to search for something in the database. So search with index, create a backup of it, restore from backup. So suppose, like, assuming that you actually uh, somehow messed up and you deleted your original database, you can restore from database, and then you can also perform operations with locks. So like, let's say you want to read one row, uh pull out the min max. So this is what it looks like, right? It's a text file with like so many, and what it needs to do is it needs to print out the output in this format. So now in this case, what you would do is, like, if you have to do this with locks, you could kind of read the file, and for every put it in database, create an index on the regions. Then for every instance of Hamburg that you find, okay, it will have an array, which, if you remember from our indexes yesterday, yeah, name index, or age index. So for every instance of Hamburg, it will have an array of positions where it is stored in the database. So you can get all those positions and try to calculate the min, the max, and the average, and do it one thing at a time by locking the table for the next region, which is, okay, I can't read that, so I'm going to go for St. John's. Okay, Bulawayo. Something. Okay, anyways, so then reading the next region, so you can perform that operation with locks, and once everything is done, you can release the lock on the table. I hope that kind of makes sense of where you can use this practically. Okay, now I'm not saying that our queries are the best. We have one in select query. The where clause does not work yet, and we will require a where clause if you are trying to work with the 1 billion row challenge, because you want to do where the name of the region is Hamburg, or the name of the region is this, or the name of the region is St. John's, or Krakow, or something like that, right? Krakow, Krakow, something. uh, so yeah, so I'm not saying it's best, but I'll slowly refine it. I'd also urge you to actually refine it, and all it is doing is basic JavaScript. Okay, and I would also suggest that you could use a library called as JSEP, which is JavaScript expression parser, and that would, I would say, kind of help you to create a more robust thing. So currently, we are parsing an expression in the query by using this new function, right? And this is what is not working exactly. And I can try and make it work today, depending on how much time we have, which is like 1 hour right now. I can try and make it work, but by using JSEP, you can actually get much richer functionality and ensure that no one can hack your, like, this new function. Okay, I think enough talk. Let's start with pushing it on npm.js. So the way to create a npm library is to, oh, also JSEP. Forgot to show that to you. So this is JSEP, JavaScript expression parser, and you could do something like the new function syntax that we had. So, like, let's say you pass it a string of 1 plus 1, it would actually evaluate that. Okay, and the output is that it's a binary expression. The operator is plus, the left side is type literal, the value is 1, the raw value is a string 1, and this is on the right hand side. Now based on this output, you can create some like switch case statements or if else statements, that if it is type binary expression and the operator is uh, greater than or equal to, then do something. Where would we use this? Specifically inside the where clause, which we actually saw yesterday, right? When we were doing the where clause, we could, yeah, we could do these operations. We could also do these operations. We could do these operations. So these are some of the conditions that we still have not added. So we could use this JavaScript expression parser, JSEP library, to do that much more elegantly and without any scare of any errors that might occur and might happen. Okay. Okay. Yeah. Enough talk. Let's push it on npm. And to do that, what you need to do is create an account on npm.js. So there you go, npm.js. You have to sign up, or if you already have an account, sign in. Sign up should be quick enough. Just add a bunch of things, and that's it. Okay. Also, might need to add what's it called? Uh, Two-factor authentication. Yes. So yeah, just basically add that. And then on our library side, where did it go? Yeah, there you go. I think right here, uh, should be very simple, at least from what I remember. We need to do npm login. Also, I've deleted the SQL syntax.txt. We don't really need to push that. So I'm going to just do a git add, git commit dash m, sure, remove unused files, git push. Perfect. And now let's do some stuff. We can do npm login. Okay. So once we try to do that, it tries to open the browser and it says press enter to open in the browser. I clicked that and it opened in the browser, and it's asking for my two-factor authentication. Okay. So I'll add that and like, mm, uh, just as a quick proof, this is what I'm getting. Now I will try and add my two-factor authentication password, which if I can actually find. Oh yeah, there we go. Okay, invalid OTP. Wow. Uh, well, pretty sure I typed it correctly. Okay, perfect. So then it tells me that authentication successful, and there we go. Now we see logged in on npm JS. Okay, and now I'm on my home page right here. Uh, yeah, that's me logged in. That's it. The next step is to actually run a very simple command, which is, so let me increase the font size here. Npm publish, and I hit enter. It tries to say, okay, this, publishing your account, and it is going like you can see the size. So env example. Uh, Actually, I'm going to press Control C because I don't want to publish the env example as a part of my library. That is something that I can add in the README, right? Uh, Git add, git commit dash dash. I'm going to amend my previous commit because, well, it's about removing the unused files. But now that I've changed, I'm going to push force. So that's done. Now let me do a npm publish again, and it says, okay, prepare rc, that's fine. Readme, it's fine. Blah 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 blah. It's fine. This is the name that it is going to go with. At the rate utk09 slash this, which is what I named in the package JSON. Okay, perfect. 14 files are going to be published. I'm going to hit enter and it opens it again. Okay, there you go. Now I need to put in my authenticator password again, which is two. No, I'm not going to say it, of course. Okay, I'm getting authentication successful, and I can close this and return to my command line. I'm going to close it, return to my command line, and there's a problem. You must sign up for private packages. Oh, right. Oops. This is somewhere. I need to define private false. Yep, there you go. Let's try it again. Why would it be private? Is it because of my name? Let me try npm publish dash dash access public. Okay, perfect, done. It is actually published. So, okay, I think because I'm scoping it, okay, that is why it was being a problem and it was asking me, oh, you have to pay to npm because you're trying to push a private package. Uh, okay, not really. I don't really want to push a private package. So that's why I said the publish access is public. Publish access is public. Yeah. And we can read all about what I have right here. So there we go. It is kind of public. These are the dependencies and all of these things. And I can actually search for my library in npm. If it hopefully it does not take too much time. Let's say if I search for this, okay, it will take some time, I guess. But it is actually there. Okay, so on my account I can see that it exists, it's right there, and there's the readme, there's something, uh, there's the code, there's dependencies and everything actually. So there we go. You can actually find the npm library by going here, and let me also share the command that I ran. So if you don't have this at the rate your name and just this, I think that should work out fine. But if you have that, then you might need to do npm publish access public. So there's this command. If you like for doing exactly what I did, if you're getting the same error that I was getting, then in that case, just run this particular command. And else you can just do npm publish. And we have achieved what we actually started, which was to publish it as a library. Now, if it is published as a library, you can, of course, download it, right? That's the whole point of publishing it as a library, that you should be able to install it. Okay. So if I create a new project very quickly, so let me create a new project. mkdir uh, my test db, cd into my sdb, code space dot. So it's opening in a new window. Don't want anything here. All I want is a terminal, and let me make this a npm. So npm init dash y, going with all the defaults. There's my package JSON, uh, and I can do n whatever I had copied npm I and this mini-SQL db. Right? I hit enter, so that should add the dependency with a caret because I did not specify some stuff. But now if I go and create a index.js file and I import something from this particular library, what can I import? Interesting. Go in here. There's a problem. So this is what happens when you hurry too much. We created an index.js, but all it actually has is these log errors, right? And this is inside the node modules. We need to fix that. We can go back to our project. We can go to index.js and we need to update this. Okay, perfect. So let's update this because, well, this is wrong. This will not allow us to use the library the way we intend to use it. So what do we need to add it here? Let me think. So we need to basically re-export everything that we had created. So we can actually do something like, and we don't really need to export the logging. Okay, that's not really needed. So what we can start with is export. What can we export from here? We can export the database path, uh, get table file path, read JSON, write JSON. And this is our storage done. Okay. The next would be schema. We can export the schema. So export something from /lib/schema.js. And what can we export from here? There's only one thing, create table. Then the next one we have queries. We can export the queries that we had created. So ./lib/query.js, and we can export the insert into and the select from here, right? Indexing, good one. So what can we export from index? We can export the create index and search with index from here. Backup, we created this backup, right? So from that, we can not ./backup, sorry, ./lib /backup.js. And backup database and restore database are two functions that we actually have there. Now logs, this is going to be interesting. What do we have in logs? And do we need to ./lib/logs.js? So logs uses mutex, and we did not have to use mutex in our test. So I think just exporting the logs should be fine. Internally, it should export the mutex. I'm going to update my package version to be 1. This is a breaking change. So I'm going to go with version 2.0.0, of course. And let me check our test DB. Did we import anything from Mutex? No, that is happening inside internally. Let me do a npm publish again, and that prompts me to enter my OTP. Uh, I can kind of make it what do you call, do not challenge from this IP address for next 5 minutes. But I think security measures are good. Okay, successful. Okay. Oh shit, I'm at the wrong place. CD dot dot slash clear CD into mini-SQL. It's good to have authentication. Uh, okay. I think this should be right place, right? Yep. Git status. Yep. Git add. Git commit dash m. And this was a feature updated index.js. That was the main thing. Git push should work. Uh, clear. And now let me try npm. I am npm publish again. Uh, hit enter, add OTP. I want to see if I have to still do publish with. Okay, I didn't. Interesting. Now if I go over to this one, reload this. I need to give it a second or two. Move all the caching and stuff that's happening. Uh, did you print this? Yep. So the latest is 2.0.0, which is good. This is somehow cached. So probably will take some time there to actually get there. I go to my package JSON and I can do 2.0.0 clear, and I can remove my package lock, delete my node modules. I can do npm install. Okay, that's done. There we go. And that's good. .env, that is one of the libraries that was a direct dependency. And Pico colors was another dependency, direct dependency. Uh, and if I go over to index.js, now I can see these are the things that I can use, right? So yeah, database path, backup database, create index, create table, and a bunch of things. So if I have to use it, what I would do is, let's say start with create table. Uh, okay, and I can basically do create table. What does it take? It takes in a query, right? What does our query need to look like for create table? It just needs to be create table users, or let's say products, where every product will have an ID, the name, and quantity. And we can also do ID would be integer, name would be text, and quantity would be integer again. And Okay, I think I have it. Let's see what happens here. And now we can do node space index.js. I hit enter, and okay, there is some error. It cannot use. Okay, this is my issue. I need to, in my package JSON, I need to do type module. This is something that we might need to fix later. Okay, there we go. Database created successfully. Product data is empty, but product schema is created successfully, which is nice. What else can we import? So there was a create table and there was a insert into. Okay, and as you can see, it also the explanations that we had written is right here. So it gives us a pretty holistic an overview of you know what exactly to do. That is why you should always have uh, explanations of what things are doing. So now in this case, it needs a query and insert into products, right? Insert into products and the names of the columns. So ID, name, quantity, values, and we'll go with our basic 101. Name is uh, what's a product name that we could have? Mobile, and quantity is like 95. And we can repeat this insert into query multiple times. 102, 103, and this is like 120, 199 of something, and 65 of something, and mobile is one. What else? Water bottle. 199 quantities of water bottle for some reason, and mouse. Okay. Uh, I think this should be good enough. And if I run this, success, we are getting everything pretty printed as well. And everything is getting inserted as well properly. Okay. Schema is still there. Now you get an idea of exactly how you can use this library, right? So yeah, any questions so far about the usage? The library is out there published. We have a version, we also added a version 2 of it. It's still cached. This is so weird. Uh, and we also saw how you could use it. So now, in any other project that you're building, you could kind of create a database, create like use a SQL-like syntax to create tables, insert into that. And as you can see, we did not actually use the database path because we had a default defined, right? Which was that okay, if something does not exist, then you could do something like you just go for default. There's also this types that we are missing, so that is why suggestions are a bit iffy. We can convert our whole project to a TypeScript project, generate types for them, or even from the JS doc that we have created. I think there is a way to generate types from JS doc that we have added, so we can have more types as well, or ship our package with types. Okay, and instead of actually pushing the whole thing, uh, we can also, what else can we do? We can, yeah, we can kind of minify this whole code. Uh, so that is also an option, actually, minifying the code. Uh, and as you can see, even though we did not export mutex, it was actually exported, right? It was actually imported as a part of the library because query needs it. Query.js needs that mutex.js. So that's it. And from a user's point of view, uh, everything is colorful and stuff. Why? Because internally we know that we are using this Pico Colors library, even though they have not downloaded it. So downloaded as part of dependency. So just to give you an overview of how npm works. Now let's come back to our project and what else? Things that we could improve. Let's start with the first thing that we should improve, that is the where clause. So I'm going to go over to my lib, my query, and let's improve the where clause. Hmm, I think. Uh, Actually, where clause as well as uh, adding the aggregations. Let's also add that. We'll do a count aggregation and an average aggregation. So insert into, I'm going to leave that as is. I'm going to delete my select query and start fresh. Okay. I'm not touching the insert into for now, but I am going to make changes to our select query. So I'm basically going to start fresh. Okay. Uh, I think I kind of prefer that over making changes and going like, oh, this is what you need to do, this is what you need to do, stuff like that. So let's do that. Let's add a description, uh, a JS doc per se. It executes a select query with optional aggregations. Okay. And we'll also do support count or supports more like, because this will already do that, count and avg functions. So this is one of the things in SQL that you could do, uh, count on something if there's all numbers and stuff. You can also do an average of all those things. So I will do that. And at the rate param is a string. First one would be the query, and this would be the select query to execute. And it returns actually an array of object. The result array. Let's do a export function select, which takes the query as an input. And now we can do a try, and we can actually, just go a bit ahead and create a parsing function. So parses a select query to extract table name, columns, aggregations. And based on the time that we have left, I'm going to just quickly add that here. So parse select query, which takes in a query. Okay, of course. And we need to add a select regex, right? So I'm going to say const select regex slash regex. And this is going to be starting with select, and then it will have a, a bunch of characters right there. Mm, plus from, and then spaces, uh, then a word right here that should come in, And then we will say brackets and could have a number of things right there, and then some spaces, uh, where, okay, and then some spaces again, and then it could have a bunch of things, and finally we close it. Okay, yep, select regex. So select whatever, okay, in brackets, not in brackets. So select whatever. So ID, comma, name from, then the table name, and then this condition of where, okay, which is optionally going to be there. And then we can do a const match equals query dot match on the select regex, which we were doing yesterday as well. Uh, this will actually not do, okay, formatting unless that error is resolved. So if not match, if there's no match, then we can, for the time being, okay, console dot error, no match. Okay. What next? Now we can do const columns part equals match of the first part dot trim any extra spaces. Const table name will be match of second part dot trim it again, and const where clause would be basically match of 3 if that exists. Okay, if that exists, then match of 3 dot trim. Else, it's not necessary that someone always has a where clause, right? So that way return null. And now what we could do is const columns is an array. So like you say that I want the select name comma ID from table users. So the columns would be name ID, these two things. Okay. And if you also have aggregations, which is like average or count, then in that case you do const. Like we need to create a array of that as well. Aggregations. Okay. So now we are going to split the columns by comma and also then identify the aggregation. Uh, so const columns split equals, also just to give you a quick idea of how exactly uh, aggregations syntax look like. It is select, and then you can do a select and then aggregation name. So select count star as, uh, and you can give it a variable name. So like let's say as my users from users, right? Or you can say select average age as my average age from users where age is greater than 10. Okay? So what would happen in that case? So if we go over to our users data, age greater than 10, so this and this goes away, but for everything else that remains, so 23, 29, 28, 32, 25, 22, so these six people whose ages remain, that would be like, they taken as a sum of them divided by 6, that would give you the average age. So the syntax looks select average age, then you do a as and like give it a variable name uh, for future use from table name, and then you can optionally add a where clause or a condition saying where age greater than 10. Okay? That is an example. How much time do we have left? We have 20 minutes. I wonder if I will be able to complete it in 20 minutes. So this would be columns part dot split on comma. We have removed all the pieces. So they should work out. Call such that call dot trim. Okay. So any additional spaces after removing it from the comma, if just splitting it from the comma, then this is what we end up with. Now we can say columns split dot for each call. We can say const count match. We'll need to add a regex or regex, whatever you call it. Or if the user is actually asking for a count, so this, and then count, and then we want to check uh, what are they asking the count on. So in that case, we are looking for a word right here, or they can go like select count star. Okay, that's also a possibility. So star, escape that, and then we want to check optionally a space, and then as is what they will have, as a plus, and then a word will be there, so w plus, and question mark dollar slash. Okay, so I think this should work out. So count match, and similarly I can copy paste this or average match. Okay, so column dot match, and instead of count this would be average, and then you would have a word, but you cannot actually take an average on the, you can technically. The average on word or the whole column, and optionally add a space as s plus u, and okay, I think this should work. If it is a count match, okay, so if the user has actually added something for a count match, in that case aggregations dot push, okay, in the aggregations array we will push a new object which would be a type count. Okay, the we'll also add a key called as column, which would be actually count match of 1, and we'll also add a alias, okay, which would be from the count match part 2, or we can give it a default if you haven't given that, which would be count. I think this should be fine. Else av- if it's an average, if the user is actually asking for average, in that case we will push in, like, let me copy paste this again, aggregations dot push. Now in this case it is going to be an object where the type is average, and instead of count match these two will be average match. Okay, so this is because of the regex, you know that it gives you this array of multiple things. So we are interested in the first part, which would actually be the column name, and the alias, which would be this, is the second part of the column, which would be the second part of the regex array. And if they have an alias, then good, else we can default it to this average, and we can actually add a else, saying if it is not count match or average match, then in that case just push it. Okay, and what we could do is return, right here I think we can return a table name columns aggregations array, And what else? Oh, the where clause, right? We can also, and we should return the where clause. So returning four things from this. Uh, we also need to write another function for evaluating the where clause. A function evaluate where clause, okay, which takes in the row and the where clause. Okay, so what are we doing here? So for a given row, it evaluates if, like, the where clause condition matches or the row satisfy. And sorry, yeah, if it will check if every given row in the table, in our case, every object in our JSON array satisfies the where clause. Every object and every, like, which key satisfies the where clause, and it would return true or false depending on, yes, this particular object satisfies the where clause or this particular object does not. Okay, yeah. So let's do that. So if not where clause, what, well, not necessary that you always have a where clause. In that case, everything satisfies the where clause. So return true. Now let's do a const condition, which is where clause dot replace. We are going to replace the column names with the row properties. Okay, so we did something very similar yesterday, and I can actually show you a split right there. So you remember this new function evaluation that we were doing? Yeah, we are going to do the same thing, but noticed that this does not exactly work properly. So I had to kind of create a new one, a new evaluation function for this, so that it works much better. Where clause dot replace, and this time what I am saying is, actually let me also add a G here, and we are going to check for multiple things. We are going to check for capital A to Z and small a to z. So A to Z, A to Z. Underscores are also allowed in the names of columns. So that we are checking. A to Z, A to Z, 0 to 9, underscore, and then star. So yeah, multiple of those, and B. So we are going to go with that there. If you find this thing, replace it with a row dot, I think dollar and ampersand. That should work out. Okay. So what is this doing? So just to explain it to you very quickly in, like, in 1 minute. So the row here, okay, the row represents each rate data that is being evaluated. Okay, each row. The slash b, it is basically saying that this is where the word starts. A to Z matches any uppercase and lowercase letter or an underscore. The second part actually matches zero or more alphanumeric characters, so it's either zero of them or multiple of them. So that is so this basically allows you to have, again, a letter, number, underscores after the first character. Okay, and this is the word boundary end. So a word, like, this is basically checking that the table name or the column name can have a bunch of things. And the slash G means a global flag. And right here, what we are saying is that take the row and actually replace the entire matched substring, wherever, which is this substring, from the regex. So, okay, yeah, hopefully that makes sense. Now we have the condition. Now we can do basically a try const function, and that is new function. And we can say for each row, in this case, just do a return condition that we created, right? And we can return the count of the row, and we can do a catch error, and we can return false. Okay, I think this is good enough for now. And now going back to our select, we can say const parsed query. I don't think I'll be able to complete this. Parse the select query, where the query is the input that you're going to give it to this function. Then const data is going to be read JSON, and we'll call the get table file path, give it the parse select parsed query dot table name, because this returns, remember, this returns an object of four things. So that's the table name, and the type would be of type data. And next, I'm not going to do error checking right now. I'm just going to go with result. If that is an empty array, in that case, uh, let's check if parse query dot aggregations dot length, because that's an array. If it is 0, that means there are no aggregations. So just do a normal select clause. Okay. Else we have to perform aggregations and then push the result into table. Okay, I think I might miss that out. So let's take a pause here. And if there are any questions, let me know at the end of session, after this session, because basically running out of time. Uh, I'll push the code. Keep an eye on the repo, and if you have any questions or anything, you feel free to put it on the Discord chat of GHW, and we'll take it from there. For now, I will take a pause here. Anything, anyone? Hopefully, you enjoyed the session. What we are doing is beyond the MVP. Uh, really, actually, we still want, like, this still has some parts of MVP, which is evaluating a where clause, which is one of the important things in any SQL database, right? So I'll add this query, I'll add the where clause, I'll push it, I'll publish it as an npm library, also make any corrections across the board. Okay, not going to minify it for now. Maybe that's something in the future. Uh, Add more conditions, add more aggregations. These are the things that I have in mind. And also, before we leave, if you want to learn more about SQL, definitely go on SQLBolt. Not a sponsored thing, it's just something that I found really useful. Okay? So you can read more about SQL with these simple interactive exercises, uh, read about them, practice them, and you have so many things. You can read about joins. Okay? What is joins and how do they work? They give you two tables and also tell you a bunch of other things. They give you tasks to complete. I think that's pretty cool. Uh, I hope we had time to actually complete it. Unfortunately, not. Anyways, anything else from anyone? Or do we are we good? We can end the session. We also had a bunch of to do homework, right? Uh, okay, so I think these are also some things that I will try and add so that our database is more complete. You already know how to use it, that I've shown you. Uh, Probably I'll try and add much more, like more descriptions if possible, much more examples if possible on in the README, so that when someone actually uses this library, they can learn a lot from that. And depending on how much time I can spend on this, I'll also try and add the JSEP, okay, for expression parsing. And okay, that depends actually. Probably I won't go down that path, but try and convert this to a TypeScript project so that we have types available. Okay, so that you get more suggestions when you use this. Uh, Anyways, I think this has been a good one. Uh, Sorry, I could not go beyond the MVP, but from the MVP perspective, I think we have pretty good joins. Oh yeah, let me also add another homework, which is that's also something that I could not show you. Okay, joins, as the name suggests, it is to join multiple tables. So let's say you have two tables. Example, we'll have a users table, we'll have a products table, and we can have something like something unique between them, and then we can join between the two tables. Which users bought which products? Okay, that's a way to imagine this. So we can do that uh, between two different tables that we create. I'll also write tests for that, so you can run the whole test and see exactly what's happening. Uh, Much more like performance probably places so that it's easy to understand and stuff. Yep, that's it from me. Thank you so much, everyone, for joining. Thank you so much, everyone who actually followed along. We'll push this right after the session and we'll make changes later in the week. Maybe probably sometimes end of GHW. Again, how much swamped I am with others. Okay. Cheers, everyone. Thank you so much again, and bye bye. Uh, Again, hopefully you enjoyed this. Next one is with Kari, where you learn about data integration part 2. Okay. Definitely go and enjoy that. Big shout out to Kari for that. Cheers. Bye.